Okay, the next lesson is on permutations and combinations. We're going to talk about the first part of section 4.2. This is actually going to be divided into 3 separate sections, but we're going to talk about the first section today on permutations. Okay, so let's go. Permutations is talking about how many ways can you arrange things. Okay, and so if we think about these 4 tiles here, red, blue, yellow, green, we're going to talk about how many ways we can arrange these 4 tiles. If we think about it in terms of what we were talking about last time, we're talking about 4 distinct slots, right? And there's a possibility that 4 things could go in the first slot, followed by 3, followed by 2, and there's only 1 left. So we'd have 12 times 2 would be 24 ways. Okay? This is called a factorial. Okay? And a factorial is when you multiply consecutive numbers all the way down to 1. Okay? I'll show you how to do this. Factorials. This would be a great time to pause, write this down, and then hear the commentary. The definition is the product of the sequence of natural numbers, counting numbers, from n to 1. Counting numbers from n to 1. It's called n factorial or n exclamation point. So n factorial is n times n minus 1 times n minus 2 times n minus 3 dot 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 3, 2, 1. This is what it actually looks like when we do an example of it. Okay, so that's the technical definition. Here's what it actually looks like in practice. 5 factorial is actually equal to 5 times 4 times 3 times 2 times 1. And if we take the sum of that, we end up with 120. Okay? An interesting note here. 0 factorial is actually always going to be equal to 1. Okay? So don't get confused. It's not 0 times something. It's going to be 1. Alright? So that's how factorials work. Permutations are based on factorials. Okay? So, here's an example of something interesting. 10 factorial, as you can imagine, is 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, counting backwards all the way down to 1. Or, if we look at this, the way this is formulated, couldn't we just write this 10 times 9 factorial? Because 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 is really just 9 factorial. Okay? And so it can also be written as 10 times 9 times 8 factorial. And you see how this could go on and on all the way up until we get to some, small number of factorial. Okay? That's an interesting way to write it because that can help us later when we start talking about permutations. Alright, so let's look at the next part. When we evaluate expressions using factorials, we're really saying do this operation, then do this operation. So if you paused here, now we can talk about the next part of this lesson. This is really going to be equal to 5 times 4 times 3 times 2 times 1 minus 3 times 2 times 1, or 120 minus 6 is 114. Okay? The next part, adding them is the same way. So really what we're going to think about is 7 factorial, which is 5040 plus 24 is going to give us 5064. There is an easy way to do this in your calculator. I'm going to let you find it. We'll talk about it in class though. Okay? And so that's exactly what we're talking about when we're using these in operations. These are expressions using factorials. It's a pretty simple concept once you wrap your head around it. Okay? Let's look at something a little bit more complex. A permutation. A permutation is an arrangement of objects in a definite order. Okay? And so the key here is the definite order. Okay? So for example, CBA and BCA are permutations of the letters A, B, C. They're distinct orders. CBA includes all the letters in ABC, but it's different than BCA. Okay? And so, how does this apply to our real life? When we look at MP3 players or DJs when they're doing their work, they're talking about permutations here because they're arranging the songs in a definite order in a playlist. Let's think about two songs. If we've got the song Fergalicious and the song YMCA, we have two songs. Okay? How many ways could we choose the first song? We could choose Fergalicious, however you spell that, for first, then second would be YMCA. Or one would be YMCA, two would be Fergalicious. Okay? You can choose it only in two ways because there's only two songs. But what about if it gets a little bit more complex and we have 10 songs and we're talking about a bigger playlist? And if we had 10 songs and we only had 3 songs to play, if we think about how many ways it can be shuffled, this is how we're going to write it. We're going to say something like this: P of 10, 3. What this means is the permutations of 10 songs, 3 at a time, because we don't know exactly what songs are going to be chosen. So we're going to take all of the possibilities of these 10 songs, chosen 3 at a time, because we have to consider all of the sets of 3, not just one set of 3. Okay, so that's what we're going to be looking at right now. And this P with the parentheses and then the 2 numbers is really this, because the NK, this is going to be number of objects, K at a time. Okay? This is what it means. P to the NK is going to be equal to n to the n factorial over n minus k factorial. Okay? So, i.e., for example, if we have P of 10, 3, like in our previous example, this is really going to be equal to 10 factorial over 10 minus 3 factorial, which is equal to 10 factorial over 7 factorial. Watch what I do here. This is 10 times 9 times 8 times 7 factorial over 7 factorial. And because I'm multiplying, watch what happens. 7 factorial goes away, 7 factorial goes away, and what I'm left with is 10 times 9 times 8. Okay? 9 times 8 is 72, so this is going to be 720 ways to choose the first 3 songs. Let that soak in for a minute. Notice I did this math here to make my life easy. Instead of making it really huge and then reducing it, I just eliminated that last part of the factorial. Okay? And so that's what we're going to be doing in these next couple of problems. Go ahead and pause and write this down. I'm going to take a drink while you do that. And let's consider that there are 10 tennis players on a team, and you, the coach, have to choose 6 of them and rank them from 1 to 6. So if we think about what we're actually saying here, we are doing the permutations of 10, chosen 6 at a time. Well, if we write down what that means, it's 10 factorial over 10 minus 6 factorial. 10 times 9 times 8 times 7 times 6 factorial over 10 minus 6 factorial will be 4 factorial. Well, where am I at? Remember, we're subtracting on the bottom here. Make my eraser a little bit smaller. So we're going to have to go a little bit smaller. 6 times 5 times 4 factorial. 4 factorial cancels. So we're left with this 10 times 8 times 7 times 6 times 5. 151,200 ways. Think about that for a minute. There's 10 players on your team. You have to rank them 1 to 6. There's 151,000 ways to do that. Okay? So if we tried to list out each one of those, that'd be impossible. It'd take so long. Okay? And so what I want you to do in this next example is you try this one. Okay? You can pause it, try this one, see what kind of insights you can get. Critically watch this. Make your assumptions, make your assertions, calculate it. I'm going to roll right through it. Top 5. Team of 8. Permutations. 8 possible, 5 at a time. So I'm going here. 8 factorial, 8 minus 5 factorial, 8 factorial over 3 factorial is equal to 8 times 7 times 6 times 5 times 4 times 3 factorial over 3 factorial, making my life easier, equal to 6,720 combos. Okay? That's how this works. Alright? There's another 2 examples here. I'd like for you to try them. I'm not even going to give you the examples though. I'm not even going to give you the solutions. You're going to have to go through them. So I'm going to flip to the slide, leave it for a couple seconds. You'll have to pause and write it down. And then I'm going to flip to the next slide. So go ahead and write this example down. Figure it out. Bring it to class tomorrow. We can talk about it. I'm going to flip to the next slide. So make sure you're pausing if you need to. Write this one down. Solve it out. See what you got. Bring it to class tomorrow. Okay? Last thing. I'm going to go through this one. 42 cars finished in the race. Okay? How many ways can you choose the top 3 finishers? Picking from 42, 3 of them. 42 factorial over 42 minus 3 factorial equals 42 times 41 times 40 times 39 factorial over 39 factorial. Boom, boom. Multiply that out. I get 68,880 ways. Daytona 500, full of possibilities. All right? Now, in these next couple of examples, we are going to go through these in class, but I'm going to flip the slides, and if you want to write them down beforehand, you can. We're going to go through them in class, though, and you can see if you can figure them out. Okay, so I'm leaving it on this. We're going to talk about this in class, though. So a couple separate problems here. Here's the last one. Alright guys, thanks for watching. I appreciate it. We'll see you next time. Be sure to bring those notes to class so we can go through the rest of these examples. We'll see you next time.